Okay, hello everybody. Today we're going to go a little bit deeper into the logic behind some of the things we do in geometry this year. So there's a lot to cover today, so we'll go ahead and get started. A conditional statement is a statement that can be written in the form if A, then B. If A, then B. So whether or not B is true depends on whether or not A is true. So the statement that comes after the word after the word if, is hypothesis. That's the hypothesis of the statement, whatever follows the word if. The conclusion is the part which follows the word then. So that's the conclusion. So a conditional statement has if, the hypothesis, then the conclusion as its structure. Okay, so the best way to see this, I guess, is to dive into an example. So let's take a look at that. Here's a statement. This is a conditional statement. If a butterfly has a curved black line, has a curved black line on its hind wing, comma, then it is a viceroy. Then it is a viceroy. Okay, so our job is to identify the hypothesis and the conclusion of that conditional statement. We said that the hypothesis was a part following the word if. So I'm going to underline the hypothesis one time. So the hypothesis here is a butterfly has a curved black, I forgot a word in there, curved back black line. Forgot the word line there. So the hypothesis is if a butterfly has a curved black line on its hind wing, the part following if is the hypothesis. And then I'm going to double underline the conclusion. So the conclusion is the part which follows the word then. So the conclusion is then it is a viceroy. So the hypothesis follows if, it's underlined once. The conclusion is follows the word then, so it's underlined twice there. Let's do that again for a different sentence. Be careful with this. A number is an integer. A number is an integer if it is a natural number. Okay, so notice the if does not come first here. It's later on in the sentence. So the hypothesis is going to be the part that follows the word if. So the hypothesis is it is a natural number, or a number is a natural number. The conclusion is then the number is an integer. So you don't really see the word then there, but you do see the word if. And the part that follows if is underlined once. That's the hypothesis. So if a number is a natural number, is the hypothesis. Conclusion, then it's an integer. So the sentences are not always written with the hypothesis first and the conclusion second. Okay. Let's do some exercises with this. So the directions here will be to write a conditional statement. That's your directions. And your sentence that we're going to use is the midpoint M of a segment point M of a segment bisects the segment. So we're going to take this ordinary statement and write it as a conditional statement, write it as an if-then statement. And so here we go for that. Or to write this as a conditional statement. So here we go for that. So if point M is the midpoint of a segment, if point M is the midpoint of a segment, then M bisects the segment. So we just took an ordinary statement and wrote it as a conditional statement with an if and a then in it. You might also see conditional statements written as a little diagram here. So we got a little rectangle here, and then we got a couple circles inside, or actually not circles, but ovals, I guess, or just whatever shape you want to call them. And inside the inside circle are tarantulas. Tarantulas. And inside the outer circle is spiders. So we know there's lots of different types of spiders, and a tarantula is just one type of a spider. So if we see this little diagram here, we can write that as a conditional. That is, if an animal, oops, I spelled that wrong. If an animal is a tarantula, then it is a spider. So whatever is in the inside circle is automatically in the outside circle because the entire smaller circle is inside the larger circle. So if an animal or if anything is in the tarantula circle, then it's also in the spider circle. So that's a way to show a conditional statement in the form of a diagram. Okay, another fun fact for you here. A conditional statement has a truth value. Has a truth value of either true or false. To show that a conditional statement is false, To show that a conditional statement is false, you need to find one counterexample where the hypothesis is true and the conclusion is false. And we'll show you that here in a minute. So again, a conditional statement is either true or false. It's true if both the hypothesis and conclusion are true, and it's false when the hypothesis is true and the conclusion is false. Okay, let's do some examples with some of this. So the directions will be determine, if the conditional is true. If it's false, give a counterexample. Okay, here's our statement. If today is Sunday, then tomorrow is Monday. Okay, so that's a true statement. Let's take another one. If an angle is obtuse, then it has a measure of 100 degrees. Okay, this statement's false, and all I have to do to prove it's false is come up with one counterexample. So I got to find an angle that makes the hypothesis true, but the conclusion false. So I need to find an obtuse angle to satisfy the hypothesis, but then say something that's not true for the conclusion. So a counterexample for that's 101 degrees. 101 degrees is obtuse, but it's not 100, so that's why that this statement is false, and I just provided a counterexample for you. Okay. Okay, so let's talk about negation. Negation. So the negation of a statement P is quote unquote not P. Sometimes you write that in symbolism with a little wavy line in front. So that means not P in the symbolism of logic. So here's something that might be fairly obvious. The negation of a true statement is false. So the negation of a true statement is false. And the negation of a false statement is true. Okay, so we see a lot of negation. Okay, now we're going to talk about different types of conditional statements in the next part. And this might seem a little bit tricky to you at the beginning, anyway. So if you have a conditional statement, like we've just been looking at, that's normally written as if P, then Q. If P, then Q. The converse of a conditional statement reverses the hypothesis and conclusion. So the converse of a conditional statement is if Q, then P. And I'll come up with some examples of this here in a minute. The inverse, there's 4 of these, by the way. The inverse of a conditional statement is when you negate both the hypothesis and conclusion. So if I go back up to my first conditional statement, the inverse of that is if not P, then not Q. So with an inverse, you negate the hypothesis and the conclusion, but you keep them in the same order. And the last one we're going to look at is the contrapositive. And to get the contrapositive, you look at the original conditional and you switch the hypothesis and conclusion and you negate both of them. So in the case of if P, then Q, now it's going to be if not Q, then not P. Okay, now we got to talk about logically equivalent statements, and then we'll do our example, and then that'll wrap it up. So we got to talk about logically equivalent statements. So logically equivalent statements have the same truth value. So they're either both true or they're both false. And I'm going to tell you which statements are logically equivalent, and then as we do our first example, actually our only example with this, you'll see what I'm talking about. So the conditional statement and its contrapositive are logically equivalent. They always agree. They always have the same truth value. If one is true, the other is true. If one is false, the other is false. And then these two, the converse and the inverse, are logically equivalent. So they're either both true or both false together. Okay, so to maybe help that sink in a little bit, let's look at one example, and then that'll wrap up our notes today, and then you're going to get a lot of practice with this stuff. So you might need to flip back here. So I'm going to write a conditional statement. So here's a conditional. That's what we'll start with. If the measure of angle A is 95 degrees, then angle A is obtuse. Okay, so we know that's true. So the conditional statement is true. If the measure of angle A is 95 degrees, then angle A is obtuse. That's a true statement. Okay, let's write the converse of that. So the converse, remember, is when you just switch the hypothesis and conclusion. If angle A is obtuse, then the measure of angle A equals 95 degrees. That's false. Because I can find an obtuse angle that's not 95, namely 96. So the conditional is true, but its converse is false. Next is the inverse. So the inverse of your original conditional is when you negate both the hypothesis and the conclusion. So the inverse of our conditional is if the measure of angle A is not equal to 95 degrees, then angle A is not obtuse. So if the measure of angle A is not 95 degrees, then angle A is not obtuse. It's false. Because I can find a measure for angle A that's not 95, so I can make that first part true, like 94. And then the conclusion is it's not obtuse, which is wrong, because 94 degrees is obtuse. So I found a number that made the hypothesis true in the inverse and the conclusion false. That makes the statement false. 94 is a counterexample. The last thing that we need to consider is the contrapositive. So the contrapositive is formed when you not only switch the hypothesis and conclusion, but you negate both of them. So look back at your conditional and then switch the hypothesis and conclusion and negate both. So we'd say if angle A is not obtuse, if angle A is not obtuse, then the measure of angle A is not 95. Okay, so if the angle is not obtuse, it's not 95 is a true statement. So notice what we said before in the previous screen, the statements that are logically equivalent. We said the conditional and its contrapositive are logically equivalent, and the converse and the inverse are logically equivalent. That means they have the same truth value. So we see that right here. So the conditional was true, and so is its contrapositive. And that always will be the case. They are logically equivalent. Same thing for the converse and the inverse. The converse of the statement was false, and the inverse of the original statement is false. So those two statements are logically equivalent. They always have the same truth value. Okay, so this stuff is going to sink in with some practice. So there's actually 2 worksheets that go with this. So you got conditional statements version 1 and conditional statements version 2. So take a look at those and get a lot of practice. Again, the answers are at the bottom for each one of those. So as you do your work, check yourself and make sure you understand conditional statements. Okay, talk to you later. Goodbye.